Hello guys, I believe you are doing great. In today's video, we are going to build a very powerful system basically that will remember the chat history from different sessions. Like maybe you told to the ChatGPT, hey ChatGPT, my name is this, and now your ChatGPT is recalling you with your exact name. So today basically we are going to see that how to do that. Previously we already built a system that will remembers maybe 7 to 10 conversation from our same sessions. So in today's video we are going to see how our system will remembers the history from different sessions. So basically we will have two agents or two node. Whenever we will ask questions or whenever we will say something, it will say come to this save memory node and it will save that history in the store. After that it will go to call model this node, and this call model node basically will fetch the history, and on the basis of that history it will generate the response. So it is the code of our previous class. This class is the continuation of previous class. If you have not take the previous class, you can definitely check that out. Here we import messages state, data class, in memory saver, in memory store. So we already see that what is data class and context, and here we pass context schema is equal to context. So let's see, it is the documentation. Let's recall this also. It is saying the check pointer saves the state to the thread. Basically it saves the state, and the store allows us to store arbitrary information for access across threads. Means with the help of this store we are able to access the information from different threads. So how to do that? Here we import unique ID, data class, runtime. Runtime is basically the environment your node is running in. That's it. Runtime is how a node access things like user info and memory store during execution. Just consider runtime a tool or toolkit that will have user data, like what is the user ID and user memory, for example, like user previous history. You may be confused about state, context and runtime, so let's revise these topics. It is saying state is basically conversation memory. This is your chat data, like hi, user said hi, AI response was hello. Context is user identity. This is who the user is. User ID may be 1 or 2 or 3. And runtime is basically access system. This is the bridge. Runtime gives access to context and memory tools. Here we create the context class and it has just only one parameter, that is user ID, and its type is string. And we also use data class decorator. We already see that what is data class decorator. Basically data class decorator is very helpful. We don't need to write the code for inert method, representation method and equality, different methods if we use data class. And we create check pointer, this instance, and in memory store, the instance of in memory store, that is store, and Chatolama's instance, that is LLM. And it is our first node that will store the memory. Whatever will pass or whatever will say something, this node store that query in the store. So here we are passing state, messages state or agent state, and runtime. In runtime there is context. We are able to access user ID by typing runtime.context.userid. And with this user ID we create the namespace, that is user ID and memories. We are able to access the last message by typing state messages -1.content. And we are saying our memories user said, we add this string and last message, this one. And here we create the unique memory ID to store our this last message, that will be uuid.uid4. And we just want to store this memory in our store. We will simply call runtime.store.aput aput, basically we are using asynchronous function, that is why we are using aput, not just the store.put method. We'll pass namespace. We are saying we want to store this memory in this namespace that will have user ID, for example 1, and memory ID will be unique memory ID against this memory, and memory will be our this memory. Like user said, like for example I like pizza, or I like biryani, or something like that, and we will return the state. It is our first node that will store the memory in store. It is the second node. In this node we will fetch the history we previously stored, and will pass that history and user query to the LLM, and on the basis of that query and previous history, LLM generates the response. Here we pass same things, that is state messages state, runtime will be runtime context. We'll fetch user ID by typing runtime.context.userid, and we'll create the namespace by using this user ID. And now we have namespace, we have user ID, so we are going to use this namespace and this user ID, and we have to search something from our store. We are saying runtime.store.search namespace, query will be state messages -1.content, and the limit will be 3. For example, previously user stored something like my name is Ali Hamza, I am AI engineer, and I like pizza, like different things. Now we are going to search from that namespace. So now user maybe ask something like, what do you know about myself? So it will fetch all the data, limit will be 3, and store the result in memories. We are saying for m in memories, m.values memory, we are saying we only need text from this memories, and we are saying \n.join. In first line there will be like my name is Ali, then in next line there will be I am an AI engineer, and in third line I like pizza. That is the functionality of \n. And with this user information we are going to create system message, that we are going to pass system message to the LLM. We are saying role is system and content is user info, this info, and messages will be system message, this message, and state messages, whole previous messages. And we are invoking the LLM.invoke messages, and will return the response. Let me run these cells, and it is the graph. Basically we are building our graph. We are passing messages state, context schema is context. We have two nodes, one is save memory and call model. Let's run this also, and it is basically the graph. We have two nodes, one is save memory and call model. So now let's call the model. We are saying config is configurable, thread ID is 1. It is too important. We're saying for update in graph.aStream, role is user and content is I like pizza. For now we are just only storing something in our store, and config is this config. Basically we are saying thread ID is 1, stream mode is updates, context is user ID is 1. User ID is 1 and thread ID is also 1. We are going to print update, and this print is basically print empty line. Let's run it. The purpose of this code is just to store something in our store or in memory. So human message is I like pizza. It is basically save memory node, and after that there is AI response also against this user message. So just you maybe ignore that one. After saving memory it will come to this call model, and its AI response is that's great, pizza is a delicious food. Now let's call this block of code, then you will know the exact purpose of this class. Here we are passing thread ID is 2. Previously we said thread ID is 1 and user ID is 1. Previously we also said user ID is 1. Mean it is the same user but we are in different thread. Let's call this. Okay, now this time we said what do you know about me. Previously we stored I like pizza. Okay, this time the query is this: what do you know about me? It is saying content is this, and its AI response is based on your previous statement. I can infer that you enjoy pizza. This time we are in different thread, but user ID is same or user is same, and it remembers the previous conversation of different threads. It is basically very powerful concept. ChatGPT and different models use that concept. Maybe in future videos we'll use these concepts also, and we'll build a very powerful system. So for now, yes, that's it, and have a great day, guys.